The intermediate value theorem, section 1.4, can be abbreviated as IVT. And that's one of those abbreviations that the AP College Board will acknowledge. So when you reference this, you can reference it by saying IVT, and they'll know what you mean. The intermediate value theorem. The most important word in there is intermediate, because that's going to be kind of the key to this theorem. If, we're going to have two ifs and then one conclusion. If f of x is continuous, on A to B, so that whole last lesson was on continuity. Did they connect? Left and right equal each other? Did the function exist? All that stuff, because we need continuity to use the intermediate value theorem. And the second if, f of A is less than k is less than f of B. First period asked a great question about this that I think really helps clarify. A and B, those are x values. F of A and K and F of B, what kind of values are those?
Y.
Those are y values. And even though we don't really know what's going on yet, we get our first glimpse of intermediate. Intermediate being in the middle, right? K is intermediate to F of A and F of B. It's in the middle of them. Let's draw a picture that satisfies those two ifs. So from A to B, and f of A is less than f of B, so that means this thing's got to be increasing. Right, y values are the f of A and f of B. X values are A and B. There's, I guess, two more things I need to do to make this fit. I need it to be continuous, and I need to stick k somewhere between f of A and f of B. It doesn't have to be right in the middle, so I'm going to intentionally not put it at the middle. I mean, it could be in the middle, but it doesn't have to be, as long as it's in between there somewhere. The in-between value theorem. K is in between the y values. Now I just need to connect A and B with a continuous graph. So it doesn't matter what I sketch in there, as long as it's continuous. It also needs to be a function, right? So you can't do this. That's continuous, but it's not a function. So don't do that. But however you want to get from A to B, it doesn't really matter what it looks like, as long as it's a function and as long as it's continuous. Then, okay, here's my conclusion. There exists at least one point at x equals c on A to B. This is one of those things where you copy down what I say first, and then we'll slow down and talk about what it means. There exists at least one point x equals c on a to b such that f of c equals k. And initially you're like, whoa, that's a lot of letters there. A, B, C, and K. There exists one point where f of c equals k. So there's one place, at least one place, and I guess the way I drew it, there might be two or three, where the function is equal to k. I can call those C1 and C2, I guess, because I ended up with two of them. There's at least one, there might be more than one, but there's at least one value of x that's between a and b. So there's the intermediate part. All those are x values. So if you want to get from point A to point B, you got to pass through k somewhere. That's the intermediate value theorem kind of slang without calculus words on it. If you're going to get from point A to point B and k is in between there, then you got to pass it somewhere. Our job is going to be finding the somewheres. Here's another way to phrase it. If the y value is intermediate, so if the y value is in between the two endpoints, then its corresponding x value is intermediate. But intermediate to the x values. So if the y value is in between, then you're guaranteed to get an x value that's in between. The y value is what we called k. The corresponding x value is what we called c. So if k is in the middle, c's got to be in the middle. Because you can't get there without crossing through k somewhere. And maybe more than once. Maybe you go up and down a couple times. But you at least got to pass it once. One way to explain it is, if I tell you to go from here to Riverwood on Kingwood Drive, I don't know how fast you're going to go. I don't know if you're going to walk or bike, but you're going to pass what's along the way? Chick-fil-A. You're going to pass Chick-fil-A at some point in your journey. And maybe you get crazy and you go back and forth a couple times on Kingwood Drive, and so you pass it several times, but you got to pass it once. If you're going from here to Riverwood on Kingwood Drive, you got to pass Chick-fil-A. If you're going from Kingwood High School to Riverwood, you got to pass Chick-fil-A on the way. That's the intermediate value theorem. Now, here's how it works, how we use it. Show that IVT applies for f of x equals x squared minus 3x minus 2 on 1 to 6 find c such that f of c equals 8.
So f of c is k in this case, right?
Yes, f of c is k, so this is k. So k is 8. So we need to make sure that 8, this is the y value, right?
Yes.
8 is between, whoops, we don't have the two y values. We have x values. So we have the x values of our endpoints. We have a and b. How can we find the y values of the endpoints? Yeah, just plug them in, see what we get. So I need to find f of 1 and f of 6, because those will be the y values. And then I will see if k is intermediate, is in between f of 1 and f of 6. And if it's in between there, then this problem is going to work. So let's see, 1 minus 3 is negative 2, minus 2 is negative 4. F of 6, let's see, 36 minus 18 is 18, 18 minus 2 is 16. So yes, f of 1 is less than 8 is less than f of 6. So the y value is intermediate. That means there should be an x value that's intermediate that gives us a y value of 8. But we haven't shown that it applies yet. I'm almost getting ahead of myself here. Show that it applies means meet the ifs, because you can't use the then unless you've met the ifs. Well, this is one of the ifs. This is if number 2, the intermediate part. What's the first if?
If it's continuous.
Right, so it is continuous, so we just need to say f of x is continuous. How do I know f of x is continuous?
It's a parabola.
It's a parabola, it's a polynomial. Either of those are fine. So I'm not worried about any skips or jumps. All right, it's got to be continuous. Right, back to the Kingwood to Riverwood example. Like if you could somehow teleport, that would be a very discontinuous operation. You might be able to get there without passing Chick-fil-A, but we want a continuous trip. Brett?
What if you just head west from here, find an airport, and fly around the world, then get to
Go back. The analogy is not perfect, so I'll just go with that. So we met our ifs. If number 1 was it's continuous. If number 2 is it intermediate? The y value is intermediate. So now we need to find the x value that gives us the y value. So f of c equals 8. Well, f of c means take the function and plug in c. And then we'll set that equal to 8, because 8 is our y value. 8 is our intermediate y value. It's the k. Now, let's hope that they gave us one that will factor. I wrote the example. Let's hope Mr. Wolf gave you one that will factor. Sure enough, for a first example, of course we should do one that factors. Because if it didn't factor, what would we have to do? Quadratic formula. But we know that. We could do that if we needed it. So c equals 5 and c equals negative 2. Now, the intermediate value theorem says that if it's continuous and the y value is in between, is intermediate, then the x value should be in between. Now, I'm going to say that one of those answers is right, but one of those answers is wrong. Which one do I need to throw out and why?
Negative 2.
Why?
Less.
It's not intermediate. Negative 2 is not part of the intermediate value that we're looking for. So it's not wrong, like we didn't do any algebra wrong, but it's not on the interval that we're looking at. It's not intermediate to 1 and 6. There was only one place that was intermediate to 1 and 6. So is it continuous, and is the y value intermediate? If those two conditions are met, then the x value will be intermediate. But make sure you only pick the value that's intermediate. This is frustrating on the test to get through all of this work and then to forget to throw out the one that doesn't work. I mean, obviously you're not going to lose a lot of points because there's a lot of stuff going on here, but frustrating to forget that little bit at the end. It is possible to have more than one, so it's not like you always get one and throw one out. You're always going to get at least one, but it's possible. Like if we'd had a starting point and an ending point there. Nope, that's not it. It's possible to get more than one answer if we had that. Then there'd be more than one answer. So be careful. You may have to throw an answer out if it's not intermediate. So if y is intermediate, then the x value is going to be intermediate. That's the intermediate value theorem as quickly as you can say it. If the y is intermediate, then the x is intermediate, as long as it's continuous. All right, that's the calculus lesson for today. I'm going to switch and do pre-cal, which seems backwards, right? Like we're hopping in the time machine and going back to pre-cal. Limits at infinity. Oh yeah, that's calculus talk. In pre-cal, we use the word asymptotes. So a lot, maybe all of the lesson today you've seen before in a pre-cal setting with asymptotes. So we're going to talk about the same stuff today, but in a calculus session, mindset. So we're going to use limits. Number one, vertical asymptotes. Seen these before in pre-cal. Do you remember what makes something or what causes a vertical asymptote?
Something on the top and bottom cancel out of a fraction.
Oh, you're close. You're thinking the right thing. He said something top and bottom that cancels. What happens if something top and bottom cancels? What does that make?
Makes a non-answer.
That makes kind of a non-answer. It makes a hole if they cancel it. So if a factor top and bottom cancel, it makes a hole. A vertical asymptote occurs when the denominator equals 0, but doesn't cancel. Because if it canceled, it'd be a hole.
Wait, if the denominator equals 0, would that make that undefined either way?
Yeah, that's why there's an asymptote there, because you can't have something there. Now, if it cancels out, it just puts a hole there. But if it doesn't cancel, there's an asymptote there. Because you get close to dividing by 0, and that sends it to infinity.
So 0 divided by 0 would cancel, but would make a hole because it's unknown.
Because you can't, so it almost works, but you can't plug in x equals 2, because then you'd be dividing by 0. In pre-cal, we spent probably 2 weeks doing things that included finding a vertical asymptote. Do you remember what you would do first on 3x over x squared minus 1?
Factor up x squared minus 1.
Good. what the vertical asymptotes would be.
1 and
Negative 1.
Okay, so that's the pre-cal way to approach that problem. The calculus way to approach that problem would be to say, find the limit as x approaches 1 of 3x over x squared minus 1. Well, first job with limits, first try is to plug it in and see what happens.
Zero's on the bottom, but it doesn't cancel.
You're right, zero's in the bottom, but it doesn't cancel, so it's not a whole,
It's an asymptote.
and is not eligible for any of the tricks. Like if it's 0 over 0, then sometimes maybe one of the tricks would work, but there's nothing here that would fix that.
So there's your asymptote.
So we're headed toward infinity. 3 divided by, right? Remember, we don't really get to 0, we just get close to 0. So we're at 0 plus or maybe 0 minus, depending on which side of 1 we're on. So if we divide by a really, really, really small number, we get a really, really, really big number. So that limit doesn't exist because it's infinity. It's going to infinity. In pre-cal, we said it was an asymptote. Now, it's the same thing, we're just describing it a little differently. As x gets closer to 1, if this is it, which probably not, but maybe. If x gets closer to 1, we're headed to infinity or negative infinity. There's an asymptote there. There's a limit that doesn't exist there. Number 2, horizontal asymptotes. Let's draw a picture, and again we'll do the pre-cal versus calculus concept here. So in pre-cal, we would say there's a horizontal asymptote at
2.
yes. I bet Miss Morris would have taken off if you just said 2, though. Y equals 2. So we've seen that, kind of familiar with that. In calculus, to sort of express the same thing, we could say the limit as x goes to infinity of f of x. So as x gets really, really big, what does that function approach?
2.
2. So those are kind of the same thing, but one way we talk about it in pre-cal, another way we talk about it in calculus. All right, we're still going to use substitution when we evaluate some of these limits. So that one's from a picture. We want to look at some equations. But again, kind of like yesterday or a couple days ago when we were substituting things that were like 0 plus and 0 minus, we're like, that's a little bit fishy, but it still worked to get us the answer. It's kind of the same thing here. Infinity is not a number, so I can't really substitute infinity, but I can do close enough and think about what's happening here. Right? 7 minus 1 divided by a really big number. Some people get stuck here.
Because they can't willingly make themselves write big.
That's right, because they're like 1 divided by big. What is going on here? If I have $1 in my pocket, which is pretty close to accurate, and I want to share it with everybody in the world, how much money is each person going to get?
0.0001.
Not much. And as there gets to be more and more people in the world, everybody gets less and less of that 0.00000, however many zeros there are. So 1 divided by big
Small.
is really, really, really small. And in fact, as a limit, it's approaching 0.
So the horizontal asymptote is going to be at 7.
So there would be a horizontal asymptote at y equals 7. That makes the connection to pre-cal. Yep. Limit as x approaches infinity, negative x cubed plus 4 over 5x squared plus 2. Limit as x approaches infinity, negative x cubed plus 4, 5x squared plus 2. So if I plug in, using the word loosely because infinity is not really a number, but if I think about what would happen as I plug in a large number,
Really big. Negative really big number.
negative really big number. Yep. How about in the bottom?
Even bigger.
Big number.
Oh, let's be careful here. It's going to be positive, yes, because of the 5x squared.
Big positive.
So, but is it bigger or is it? I mean, it's big, but is it?
Slightly smaller?
It's less big,
Big minus 1. Just put big
right?
minus
Because it's
1.
cubed versus squared. Like cubed is
Giant big over little.
Yeah.
Number 5.
Define big.
the 5's not going to matter once you start plugging in 100 or a million.
Larger than 3 though.
5, but you're looking at what you need to be looking at is the exponents. Is the exponents.
A negative.
So-
negative
What do we think this is headed toward?
and
Yeah, negative, large, negative, really, really big. Because the top is bigger and getting bigger. Bottom's big, but not as big. Because we're looking at the exponents. A cube is going to get a lot bigger faster than a square. Right? Even at just 10. 10 cubed is 1,000, 10 squared is 100.
that just. Wait, there's 2 parts.
Oh, there's 3 parts to this one.
What?
Let's flip those and see what happens. So I'm going to take the same fraction but flip it over.
So 5x.
So it would be
5x squared plus 2 on top. Hold on, don't call it out loud, but you're probably right. 5x squared plus 2 on the top. Negative x cubed plus 4 on the bottom.
A positive little big over a negative big.
It's Ryan, you're wrong.
No, Ryan's right.
No, you said positive, it'd be negative.
Well, he said
Negative big,
positive
big.
little big over negative really
It
big.
doesn't matter, we don't have a single number in that equation.
Well, what's a big number divided by a really, really big number?
Big number.
Pretty big
It
number.
depends on
Wow.
But this one's getting bigger and bigger and bigger faster than the top one's getting bigger.
So it's kind of small.
So really
So
small
it's
number.
0.
In fact, in the limit, it approaches 0.
Y would be.
This feels like a
The
seventh
asymptote
grader
would be
who's just
y
like,
would
I don't
be
want to have
0.
to do math, so he just starts writing down random words.
All right, last
Looks
example.
like you gave up on a test.
Yeah.
5x cubed plus 2x
What?
over negative 2x cubed minus 7.
So positive big number over negative big number because.
And how about the magnitudes of the top big versus the bottom big?
It's positive big divided by negative big. Clear distinction. It's not that.
I think I would disagree. Because they're like equally big. However big they are,
One
they're
letter.
equally big.
But also, one of them
Luke,
is 2 times that.
say that again.
5 over negative 2 over 2 is they're the same, so look at the coefficient.
Yep. And you can ignore this stuff because when you plug in 1,000,000, who cares about -7 or even 2,000,000 once you've cubed it? So you can ignore the smaller stuff. That leaves you with 5x cubed over negative 2x cubed, which reduces, that's maybe not the right word, but as x goes to infinity, yeah, you're right. This is negative 5/2.
Because forget about the white stuff.
Because the bigs are the same bigs.
They cancel and make a whole.
Correct.
What?
All right, so here's the shortcut. As x goes to infinity for horizontal asymptote rules. There's the shortcut out to the side here. Last year in pre-cal, I think I taught Bobo Bot eats DC. Do you remember that?
What?
The Miss Morris people don't know what I'm talking about. Miss Morris people might have it better. Top no, bottom O equal co.
I don't remember this.
Okay, maybe she didn't teach that.
No. She probably did. I mean, I'm terrible.
So for the Bobo Bots each DC, let's see. Bigger on bottom was this one. Bigger on top was a slant, or in this case, no. And if exponents are the same, divide the coefficients. So it's two different devices to remember the same thing. But most calculus folks just go with top no, bottom O equal co. Assignment is not the same as what's on the calendar, Ryan, so go with what I'm writing here. It goes to all of that. Page 81, 95 to 98, those are, do all of them, those are the IVT problems. And then page 88, 1 through 7, 13 through 19, 29 to 39, odd.
Is that eats?
Exponents are the same, divide the coefficients.
Okay.
So it makes a funny saying if you read it the other way, Bobo Bot eats DC. Or top no, bottom O equal co. It's the same thing.